So on to the second speaker of the morning. As you, I'm sure, are well aware, there's a monumental environmental disaster happening in the Gulf. And the oil spill going on there is causing a great deal of activity in the federal government. And because of that oil spill and because of the response that's necessary in multiple agencies, the speaker who was originally scheduled to appear here, Marcia McNutt, the director of the USGS, was unable to attend. We do, however, have from the USGS John Haines. John is currently the Coastal and Marine Program Coordinator for the USGS, and he will be covering the topic Marcia McNutt was intending to cover. At the USGS, John leads a coastal and marine geology program supporting research spanning issues including storm, tsunami, and earthquake hazards, coral reef health, sediment and contaminant transport, gas hydrates, and sand and aggregate resources. John represents the USGS on the Joint Subcommittee for Ocean Science and Technology. He's co-chair of the Interagency Working Group for Ocean and Coastal Mapping, and he's a co-lead for one of the Ocean Research Priorities Plan near-term priorities, forecasting coastal ecosystem response to persistent forcing and extreme events. John received his PhD in physical oceanography from Dalhousie University in Halifax, Nova Scotia. His thesis research developed and applied statistical tools to decompose multivariate data sets and identify the structure of infragravity wave fields over complex nearshore topography. He participated in and led regional coastal erosion studies in Lake Michigan and Lake Erie, and John was appointed to his current position at the USGS in 2001. John Haines.
Thank you for that introduction. That was more than you need to know about me. I'm not Marcia McNutt, and everyone in the room is disappointed by that. And in fact, I'm disappointed. Not because I'm not pleased to be here, but Marcia is the director of the USGS, the science advisor to the Secretary of Interior, and she comes from the oceanographic community. And so she was excited to come and speak to her community. Initially about the role and future for the USGS, but then clearly it was going to be about the oil spill. She thought that was an appropriate role for her to play. Well, it turns out Marcia has been in Houston since the 7th of last month. When the Secretary of Interior allows her, she may leave for a day to go brief Congress, and then she's back. So Marcia couldn't make it today. And this tells you something about the disruptive effect of the oil spill on all of us, and of course, that's a minor disruption compared to the impact this is going to have. And that impact will be long-term. And one thing we know is that it will require an engagement of the entire scientific community to do the best we can in the face of this disaster. All right. I'm kind of a walk around, wave my hand, yell at people speaker. I'm nailed down by the microphone. That's a problem. But more importantly, tone is a problem with this topic. This is not an optimistic scenario that we're facing in the Gulf of Mexico. Every day, I begin the day reading the papers, and as all of you know, more and more pictures showing up that are absolutely gut-wrenching of the impact on our coasts and the wildlife. I read the daily situation reports from the Department of Interior, from NOAA, from EPA, from all the agencies engaged to see how much is going on, and every day how new people are on alert and frankly frightened about the impending impact on those resources that they are trusted to protect. Here's a little bit of some of the numbers. These change daily. What do you get from the numbers? 4.5 million feet of boom have been put out. On any given day, there are near 3,000 vessels deployed to respond to this spill. Over 50 aircraft. It's a huge effort. They're big numbers. I am not going to put up pictures of oil-soaked wildlife. Just not going there today. All right. So the role of the USGS. I should caveat this. The USGS is not the whole story. It's the place I live, the place I work, an agency that I'm very proud of, but I see lots of name tags from EPA, from NOAA, from the Corps of Engineers, across Fish and Wildlife Service. I believe the last number was 25,000 as of yesterday, people deployed to respond to this. We're just part of it. We are, within the Department of Interior, we are the nation's natural science agency, and I say that without saying we are the agency for DLI. We are the agency, natural science agency for the nation. We do have a special relationship to provide the science that those DOI bureaus, Fish and Wildlife Service, Bureau of Land Management, Park Service need. We're an independent research agency, and science is our mission. And it is genuinely science in partnership at all levels. We have about 9,700 employees in every state and around the Gulf in particular. And why is the USGS involved in the oil spill crisis? It's a kind of a silly question. Probably shouldn't have phrased it that way. We have a huge breadth of expertise in the USGS, and probably many of you work with USGS colleagues, hydrologists, biologists, geographers, geologists, of course, but also geochemists, modelers, social and economic scientists, and those will all be needed in this response to the oil spill. We have a history of interdisciplinary research and model development, not by ourselves, but with our partners, and believe me, this is not a chemistry problem. It is not a biology problem. It is not a geology or an oceanography problem. It is not easily categorized as a discipline-specific problem. It is going to require integrated, multidisciplinary science from the basic, foundational, physical, chemical, biological sciences all the way to the social and economic sciences. No question about it. We have an institutional ability to sustain long-term and regional scale research efforts, and we'll come back to this repeatedly. This is going to be a long-term endeavor. We have direct contact with the resource management agencies and the DOI land holdings, where we have a long history of research working with the Fish and Wildlife Service and the Park Service, our natural laboratories to categorize and understand the impacts of this oil spill. All right, so here's a tone issue. Natural laboratories. Isn't that a horrible way to think of them at this time? But in some respects, we have to remember there are huge scientific opportunities here, not only that should improve our response to the current oil spill, but in the long term, teach us more so that we can do better in the future. So here's the Gulf of Mexico. This is the first thing I pull up on my BlackBerry every morning. Where's the oil spill? Where's it projected to go? Who's worried today? As you can see, the potential impact goes from the Texas shoreline, off the map, around to the Keys and the coral reef systems, and in this box we have wetlands, we have beaches, we have important fisheries, wildlife habitat, some of them deep below the Gulf that we rarely see. We have just every bit of what the nation values is present and at risk in the Gulf of Mexico right now. So, to be honest, we are still in response mode. What do we need to do right now, today? But at the same time, we're starting to think about recovery mode and the long-term need. And some of the things that we know are that these impacts and the effects and our ability to anticipate them over time has to cover a wide range of species, ecosystems, the services they provide, and cultural resources and coastal communities as well. Again, this is a manifold and complicated problem. Now, we've had tragic oil spill events in the past across a variety of scales. Exxon Valdez being one in particular. One of the first things that the director did when this oil spill occurred was she went to all the people in the survey who have worked and are continuing to work 20 years later on the Exxon Valdez spill, And she went to all the retired people who in the late 60s worked on the Santa Barbara spill and said, what do we know? What did we learn? How can we do better in this case? And there are some lessons, and some of them might seem a little obvious, but they were reinforced. The passion of the people who have worked on these past spills is incredible. First of all, you have to think long-term regarding the impacts and the recovery. In the Exxon Valdez area, 20 years later, populations, individuals, and communities still have definable, notable impacts in their reproductive success, in their size, in their very existence due to the Exxon Valdez spill. We have to consider both offshore marine and coastal ecosystems and multiple levels of the food chain, particularly in terms of understanding the long-term impact. Some of the most diagnostic and clear information comes from the sessile marine organisms, the barnacles, the other things that don't move, the benthic infauna that are consistently in contact with oil residues. And in the Gulf, this challenge of linking the marine and coastal ecosystems is going to be especially critical. This spill occurred at a depth and a distance offshore that is new and different. And much of the processes by which that oil gets from 5,000 feet below the surface up and to the shorelines is critical to its impact and also largely unknown. Pre-spill data is critical for assessing injury to resources and recovery. And they told us that again and again and again. If you don't know what's vulnerable and valued now, you don't know how to respond. And frankly, you won't know how to assess the impact and the damages in the future. There is nothing that should take precedence over pre-spill understanding of the conditions prior. And then in the long term, damage assessment. We'll come back to that. And of course, natural variation in marine and coastal ecosystems will confound the understanding of recovery. And I got to say that as well, the things we do in response to the spill will confound our understanding of the recovery. Massive, massive undertakings are going to happen to try to help mitigate these impacts, and that in its turn will have impacts. Oh, so a couple of other things. Causality. We talk about damage assessment, and that is a big part of what we're doing here. And when we hear that, we tend to think, all right, that's a part of a legal process. All right? Well, it is, partially. But we are now in an environment where we have, in response to the oil spill, natural resource trustees and a responsible party, and the decisions on how we move forward and who pays for what and what the long-term plans are all depend critically on the assessment that is diagnostic, linking the presence and the effects of oil on the ecological response that we see. All right? Causality. That's why they came back to us time and time again. You must get the damage assessment right so that the science can be at the table to say, these are the actions that we need to take. There's another consequence of that. Everything may be arguable and contentious, and the standards for custody and control of evidence and analyses is going to be stringent. We need all the help we can get from our partners in all agencies, in the states, in the academic community, but it's not going to be as easy as it normally is. Because every bit of evidence, every bit of science will be subject to a scrutiny that is not perhaps, we wouldn't like to say harder than the scientific scrutiny we normally give, but it will be different because it will have these direct decision-making implications. So the USGS has started to think about how do we want to be in this in the long term. We've also started to talk to the other agencies about how do we work together to be in this for the long term. And so this is the schematic that our science planning group has put together. It's titled Science Themes. It's not entirely science themes. Pre-impact assessment, that's not a science theme. That is just the number one job. And that will evolve into continued monitoring, development of the observational and empirical base, damage assessment, all those things. That will be there with us for a long, long time. The primary science themes, the next three that have been outlined: volume, fate, and transport of oil contaminants. Here's how I interpret that. We have a new physical chemical environment in the Gulf. It is what it is today. It will differ greatly over the coming years, months, decades. This is a biologically active, reactive, chemically reactive material that's been introduced. It will bind, it will accumulate, it will resuspend, it will be available in differing ways in differing places over time. It's a key component of understanding the Gulf now and into the future. What is this new physical chemical landscape about? Near and long-term impacts on wildlife and coastal ecosystems and marine ecosystems. This is obviously a key piece of the science planning and the needs for mitigation. Impact on communities. All right, as we go through these, some of these things the USGS has substantial roles in, some less so, some niche roles, some broad roles. Impacts on communities. That's the other gut-wrenching part of the story. The fishermen, those dependent on tourism, those who have made the Gulf their livelihood and part of their culture for many, many years are going to be impacted economically. There will be public health impacts. Those are less about the USGS, though we have valuable scientific information to provide. There will also be secondary impacts. As the wetlands respond, as the beaches and barriers respond or are modified, how does that change the resiliency of the coastal communities to hurricanes, to storms, to other processes? This is all going to be part of this. Really, if ever there was an experiment in ecosystem-based management, this is going to be the one. From ecosystems in the general sense that we think of them to really grasping that broader sense where people are a critical component. And finally, this all has to be driven to provide tools to aid long-term recovery. So I'm going to step through those a little bit. Let me just catch up where I was on my slides. There's a little bit of chronology in that list as well, because right now, top of the list, pre-impact assessment, believe me, that's where we are. That's where we're focused in many respects. The USGS has taken water, sediment, and benthic samples, including in-fauna, microbial communities at 70 locations. This was about a week ago. It's expanding as we start to consider a broader range for this spill. We're not the only ones doing this. EPA probably even more so engaged in this baselining. What is the presence of hydrocarbons in those systems and organisms now, and hydrocarbon byproducts? All the things you need to know, and how do we fingerprint those to distinguish them from what's coming? And we have to do it consistently across all the participants. 5 different pictures of this process aren't as useful as one coordinated picture. Submerged aquatic vegetation and mangrove surveys and ground truthing. We immediately went out with vessel deployed, video and sampling systems to key areas from the dry Tortugas up to the Mississippi Sound and around to get the best information we could on condition of those resources prior to impact. One of the big successes, if we can feel we have successes in this time, is remote sensing, productions of map, and GIS layers. Okay, so here's a positive message that comes out of this. For a number of years, there have been broad efforts at the federal level through the Federal Geographic Data Commission to coordinate geospatial information. There have been outstanding efforts across the federal agencies and beyond to coordinate coastal and ocean mapping. As it turns out, that's paying off for us. We not only have more information, but we have more ability to integrate it and turn it into appropriate and useful products in a short time. And that really has been a success story in some respects for bureaucracy and planning, but it does pay off. It does work. Fish sampling, not going to go there, not my field, but that's taking place across various species and populations. And it is important. If you don't know the population and some details of the structure of that population and subpopulations, damage assessment becomes impossible. And we'll come back to that. Avarice. This is the advanced visible and infrared imaging system that is giving us, collected by NASA and NOAA, much of the analysis done by the USGS, who actually developed some techniques for mapping water on Mars. Turns out that can be repurposed, and we're using it to track the oil on the surface and some information about the quality and thickness of that oil. And inundation maps, which we come back to in a little bit. Am I backing off too much? Let me know, just yell at me. Oh, inundation maps. I was looking forward to this slide, one I actually know something about. So, baseline information. It turns out the USGS, NOAA, NASA, the Corps of Engineers have committed over the past 10 or so years to have LiDAR information that gives us accurate information on the state of the shoreline, updated after every major storm, elevations, vegetation cover, and we needed it, and it was there. A sustained effort pays off. We also had an ongoing effort to provide assessments. What's the vulnerability of these regions to coastal storms? Well, those processes will carry oil into the beaches, the dunes, the wetlands, and so we've repurposed those inundation models to be now not about waves and surge attacking, but carrying oil. Where are we likely to see oil, and where does it intersect with what we consider valuable? That's a success story. And I think a lot of the success stories we have are going to, for the entire community, point out sustained monitoring, observations. You're on the right track when you do that. Coordination is important. And yes, you can repurpose when you have scientific understanding that's fundamentally important to how the ecosystem behaves. All those things pay off. We ought to be investing more in research. The volume of oil. Oof. Here is a politically sensitive issue. How much oil is coming out of that well? Director McNutt was asked by the Secretary of Interior and the White House to lead up the group to come up with a credible estimate, a scientifically sound estimate of the oil flow. It is made up of federal scientists, independent experts, lots of university engineers, oceanographers, others, and they looked at 3 different ways of estimating the oil flow. And on the basis of those 3 methods, the sweet spot, where there were consistent estimates within the error bars that they put on it, was 12,000 to 19,000 barrels a day. Will this estimate change? Probably. Probably. There still are. And there was a newspaper article the other day about this that said, well, scientists say there are unknowns in the system. Damn scientists. We're always pointing out we don't know everything. And it doesn't add clarity at certain times, but it's true. There are unknowns in this system. One of the big ones being oil from 5,000 feet to the surface, with or without dispersants. How much gets where? How is it transported? And where does that make it accessible to this kind of assessment? So the assessments will be further refined. The first effort was a mass balance effort. How much oil do we see on the surface? How much do we know we've picked up or estimate we've burned, or do we think has disappeared through evaporative processes? Just an effort to do the best job at a mass balance of the oil that's out there. They did have the methodology peer-reviewed and published, and they came up with roughly the number you've seen, the 12 to 19,000 barrels a day. There was the Plume Group, who basically, and I think probably most of you have seen something about this in the paper, on the basis of these video imagery, which is addictive and sort of sucks you in watching it, what can we estimate about that plume? And again, I'm going to catch up with my notes a little bit. And so they did the best they could with the video available, and there will be more and better video. They had to make some rather difficult estimates on plume velocity from what they see, on what else is coming out of that pipe in terms of gas, hydrates, and water, and how much is entrained as they view it. And so they've established a lower bound with wide error bars. The lower bound, in their estimation, is somewhere between 12 to 25,000 barrels per day. And then comes the RIT assessment. This is the most straightforward in some respects. This is the riser insertion tube option. That was very many options ago in the saga of what are we doing about this oil. This was the tube they inserted to try to directly capture the oil. So very simply, how much did we capture and how much do we estimate from what we see from the hydrologic properties of the flow that we're missing? And so they, again, only put a lower bound on this of at least 11,000 barrels a day. So this was a USGS-led effort, but by no means exclusively or even primarily USGS research staff. So we've gone through baseline assessments. We've gone through the physical process of oil moving around. That's where most of the action has been to date. The fate, well, what we're doing is preparing to be able to do the best we can, understanding the fate of this. Characterizing the source oil and the dispersant. The more you know about what came into the system, the more you can track it, the more you can understand the decay products that result, and the more you can distinguish it from other oil and other materials out there, which is critical, again, to the damage assessment product. So a number of the geochemists are taking a lead on a number of analyses of samples and how they interact within biota, within the water column, within the sediments. And working on the temporal attenuation, biodegradation of the oil. This is a critical piece not only for the impacts, but also to keep us with an accurate picture of what we're dealing with as it shifts in time. Right now, they're still pouring the stuff in the bottom, but things are happening to it on the top that are changing what's available and the nature of what's available to interact with the ecosystem. Landfall data, this is getting, well, the list of places, the list of amounts just continues to increase day by day. The transport of oil spill contaminants. Projections of where surface and submerged oil will travel. So how do we anticipate where we're likely to see it next, where we're likely to see it in the long term, how we deploy the assets we have to do whatever we can do? Part of this is about oceanographic modeling. There's another success story here. If you're in the oceanographic community, as some of you are, probably the biggest emphasis of that community over the past decade has been this idea of an integrated, sustained ocean observing system. We need that network of observations and built on that network of models that will allow us to provide the information relevant to oil spills, but ecosystem and fisheries management, to hurricane formation, to hazards, just that fundamental information. It's not where we would like it to be. It's not where it was anticipated to be. But here's one area where that nation effort is paying off. There are a heck of a lot of models out there. None of them are appropriate for all the things you need to do and understand. The deep models may not link with the shallow models. Some models incorporate biology, some don't. Some are good at tracking particles, some aren't. You need to hand off between the models, and the output from those models needs to be available to all the researchers and responders who could use it. And there's a framework in place now to make model output from multiple models not only available easily with some standardized open source tools, but also integratable with those data resources that people have and need to really see what's happening, not just the model picture behind it. There's a success story there. It's one we'll have to build on tremendously. The inundation models we talked about, coastal zone processes. I'm a coastal zone oceanographer. It's the most complicated piece of the landscape anywhere, anytime. I say that because I don't understand it. It's my piece of landscape, and it befuddles me. But this interaction from barrier islands to wetlands, to back bays, the marshes, all, each in their own right, incredibly important as habitats, as mitigators of coastal hazards, and all intimately linked. When one goes, the rest follow in some way, in some form. We don't have those linked landscape and ecological models. Mitigation efforts. We're going to come back to this one largely because the guy who put the slide together put it in a different place. But anyhow. Near and long-term impacts on wildlife and coastal ecosystems. These are the bits that many of us care about the most. And we know from past experience, oil and dispersants will impact all levels of the food chain and will have adverse impacts on the resilience of coastal wetlands. And as huge as the short-term impacts of the oil are, the consequences of the actions we take to mitigate them are likely to be just as large. You know, we steam cleaned the coast of Alaska after Exxon Valdez. Turned out that wasn't necessarily the wisest thing to do. However, you could do it. Marshes and floating marshes and wetlands and our tools are pretty limited, and those that are drastic, burning, have consequences that are going to be large. And as the primary nutrient source for all these fisheries and all these populations, what we do to those marshes is going to have a huge impact. What is done to the marshes and what we do to them. We have to determine the spatial extent and degree of damage to coastal ecosystems. Some will be more resilient than others. Support the development of remediation and restoration plans. And deep coral studies. So it's not just coastal ecosystems, it's these deep marine systems as well. And here's another, I think I've said success story a few times. Maybe I should say we got lucky. Here's another place where the value of investing in the science early so that you have it when you need it is clear and compelling. Chemosynthetic communities, methane-based communities on the floor of the Gulf, deep corals and mesophotic corals have actually been the focus of the last decade of a number of research efforts. The USGS, the Minerals Management Service, NOAA, the academic community, all working together with AUVs and benthic landers to monitor the oceanographic conditions, looking at the microbial communities, looking at the genetic structure of these communities, understanding what the fish associations and assemblages are in these communities. Two of the most studied are the Lophilia reefs within about roughly 25 and 35 miles of the Deepwater Horizon site. We know a lot. Damage assessment, unfortunately, will be rather simple there. We know a lot. But we also are planning the beginning of next month to go back to those reefs, to bring back organisms and corals so that we can challenge them in the lab and find out not just how do we think they react to these materials, but how do they actually react. And there's a real unknown about what they see. There are no oceanographic instruments there now. We don't know what they see from this oil dispersant mixture. Does it pass over them? Does it rain down on them, embedded in biological materials? We don't actually know. But we have a lot of information on which we can gain that understanding. We talked about impacts on coastal communities, the economic impacts. One of the prevalent themes in the oceanographic community is we have to engage the social scientists. I think it's a theme in every scientific community, a natural science community. In order to effectively translate what we know and to provide the right information so that people can make better decisions and people's lives are improved, we have to improve the social sciences, and that is absolutely true here. We have modest capability within the USGS, but it's going to happen with the other agencies. Cultural resources and archaeological sites, obviously within the Department of Interior, we care about those. Current community exposure to hurricane hazards. This is this secondary piece. You change the Gulf, its resiliency and resistance to all the natural processes it's faced forever change dramatically. And coastal communities 1 year after the oil spill is just a shorthand for saying we're in it in the long term with these communities as well. Many of the impacts, and this is the same area that was hit by Katrina, will be short-term and acute, but there will be chronic impacts that have to be assessed over time as well. So let's talk about this berm. The state of Louisiana, the governor, almost immediately proposed hundreds of kilometers of this sand berm to protect the barrier islands and wetlands. And, okay, so some of you, I can see this actually, some of you are going, well, that's a wacky idea, isn't it? Maybe, maybe not. I mean, hard times demand some tough solutions, but we do know some things. So can we translate what we know to do the best and most efficient job that can be done? And some of the things we know, having looked at these barrier island systems through Katrina and Rita and hurricanes going back 50 years and watching them actually decay and erode to barely functional as it is we know something about how they operate and the role they play in the system. The initial proposal, and this is, I believe, Breton Sound, Chandeleur Islands, it's an arcuate, old delta lobe along the front, was to go offshore that entire 60 to 80 kilometer reach, kind of dig a trench and pile up a berm. In about 6 meters water depth, it would be 300 feet wide at the water line. It would go 6 feet high. In other words, far higher and more massive than those islands currently are. Now, here's a thing that many people don't know. There's not a lot of sand off the shore of Louisiana. There's lots of mud and fine stuff, but really, primarily sandy material is in thin supply, and if you take it from the depths they propose to take it, what you're basically doing is destabilizing those barrier islands, and you're increasing their potential to erode. They're taking it from the wrong places. So we pointed out, here are where the sand resources actually exist. You need 56 million cubic yards for Breton Sound, and you need 36 million cubic yards for the areas to the west of the delta. And if you don't take it there, you're definitely doing damage at the same time you're trying to save these resources. As we move on in this process, there are real questions about how what is now a porous and fragmented barrier island chain, which does protect the wetlands and greatly controls the circulation in those productive back barrier nurseries, what's this berm going to do? How's it going to alter the hydrodynamics, the exchange of living organisms and nutrients and all those other things across the system? That's going to be a scientific question that's very important to assess the impacts and how much of the impacts are due to our response. It's going to be one of the great, if I can sound a little enthusiastic and not too positive, because this isn't a time for that, but one of the great sediment transport experiments of all time is about to happen. Massive amounts of sediment in a sort of proto-barrier island system, which we think we know what it's going to happen to. We'll see. One of the other issues, though, is I've said sand is in short supply. They've proposed taking 100 million cubic yards, which in the long term we think is needed for genuine restoration of this area, and put it into a sacrificial feature which we know is going to go away. It will play an important role, we hope, but it is not long-term restoration. So we've used some of the currency, sand, that we have for this response. And lastly, decision tools to aid response and long-term recovery. We've shown great success in the role that geospatial information plays, and we've got to continue to do that and expand it to all the things people care about. You got a map of that landscape. What you put on that map is critical. Do you care about infrastructure, cultural resources, wetlands, fisheries, the entire function of the ecosystem? We have to be able to explain the vulnerability and value of all those things to the people who are going to make decisions. Obviously, tools to facilitate the response, modeling tools, and model of changes in ecosystem function and impacts. Sort of boilerplate about decision tools. All right, I'm getting very close to the end. So Marcia's made about 5, 6 round trip, come to Washington, go back to Houston, when the Secretary of Interior allows her. One of those trips was to organize with John Holdren, the President's Science Advisor, a science summit on May 19th. And it was to bring the oceanographic, primarily academic community in and say to them, We know you want to help. We need every brain that's available. And Marcia is, in particular, very committed to this, making sure that our entire science portfolio, from operational and mission agencies through basic and fundamental research community, is brought to bear, really for all issues and all time, but in particular in response to this event. And the notice went out, be at the White House Conference Center tomorrow. And 30 or 40 members of the academic community, turn out from the West Coast, a little light, as you might expect, were there. And they discussed the issues that had to be addressed. And I love this bullet, strong agreement on issues to address. This is how I would put it. Strong agreement that there is no limit to the number of issues that need to be addressed to do the best job that we can do on this. And some of them are confounding issues. How do you sample oil at depth when you have to drop all your instruments through oil to get to the oil at depth? These are not easy questions by any means. But we are, as an oceanographic community, in a position where this is a challenge to us to prove that the tools, the technologies, the systems, the collaborative mechanisms we've been pushing for a long time work. And it's clear some of them do. All right. The deployment of gliders, autonomous underwater sampling systems that will cruise the Gulf in a programmed way. Everybody's got one or two because it's not an operationalized thing. It's very much in the R&D stage, but they're all going to the Gulf. And they're paying off. And they're showing that this investment that we had said need to be made if we're going to sample this vast ocean appropriately is worthwhile. Other AUVs are important. The new sensors that have been developed, satellites, boy, it's never, turn it around. It's always worthwhile to point out satellites can't do everything, but boy, can they do a lot for you in providing the right context and some information that there's no way to get otherwise. And finally, we're taking advantage of this concept of ocean observing systems. And not so much because we have that many more sensors out there than we would have otherwise, because we have an infrastructure for bringing the information, the observations we do have, and the models together in a way that's effective for all the people who need to use it for so many different things. So this is my last slide. President Obama, science is more essential for our prosperity, our security, our health, our environment, and our quality of life than it has ever been. And that's been a consistent message from our president, and it's been consistently put forward by his science advisor that the president gets it, and he's all about it. Well, here's the challenge for the scientific community. The killer application of all time, however you want to think about it, to prove that, in fact, this is true. And the last thing I want to leave you with as a lesson from the Exxon Valdez is virtually every important resolution, arbitration that led to a change in how we did things, a settlement of a question, was based on science, sound and credible science. We know we can make a huge difference. We want to make even more of a difference than we're imagining currently. So thank you all very much.